Welcome everyone to Cloud Computing and Big Data. Today we have our practical lecture 11.1, and this is really a practical lecture where we do some data mining algorithm, and of course we will set up basically the environment for it as well with Jupyter, understanding differences between Jupyter Lab, Jupyter, and then also thinking about a little bit, the algorithms that you have already seen in conceptual lecture 11. And then we will move a little bit to recommended techniques in clouds, using there the Google Colab environment, for example. But before we go into the material as usual, let us discuss what we had the last time in our conceptual lecture 11. And this was an invited lecture, thanks to Shadi Barakat, one of my PhD students who recently graduated, is now a postdoc at the Uli Supercomputing Center. And all over his PhD, and now he's really a practitioner, as you have heard, in terms of big data analytics, data analysis, data mining, and so on. And we will also discuss a little bit again today that many of these techniques are a bit overlapping in terms of terminology, right? When it's basically data analysis, data analytics, we had this before, and you see here suddenly also deep learning. So we started basically the lecture last time where Shadi was alluding to the typical example that you have in shops. You have a basket, as some people would say, where people just have market transactions, if you want. So basically, what are the things they really bought to? And normally you can basically model this a little bit as a comma separated list here, for example. And you see here the famous example that also Shadi was using with basically having here a grocery store. So what you would buy there, you see here row by row, those items which are basically in the shopping baskets of individuals. The individuals that we don't know, that will be important differentiator today to, other recommender engines and so on. But here we're talking about individual transaction. And the question is, can we learn something from it? Is there a pattern of, let's say, frequent item sets, which is, let's say, the first step where we say, well, these are actually commonly and frequently used while shopping. And then can we do something that is alluding to association rule mining? Is there a sort of, rule that we can obtain for it? So, and you see the example that Shadi was giving was the diapers and beer example, where we say, okay, these are actually frequently bought together. And when we do this association rule mining with different algorithms you have seen the last time, then we come to some form of rule that those that typically buy diapers, they also buy beer. And he also unlocked the secret, I think, last time and said, well, people that have kids, and often buy diapers have no time anymore to go to the pub. So hence they buy beer for home. So in the end, I think pretty obvious. Now think about this as a big data course. Here we're talking now about big data analytics, where maybe you don't have this 5 transactions, but the transactions are in the million, right? And you saw already here on the right-hand side, the transactions number that going quickly up to 4,000. And if you think about you need a million or so, you can see that several algorithms in terms of big data analytics are smarter, like the FP growth, for instance, here. But also some of them seem to be not scaling so much. So if you extrapolate this and go back to, let's say, millions of transactions, you will see that the execution time of some of the algorithms will skyrocket. And this is, of course, the difference, if you want, a little bit between the different algorithms that also Shadi showed the last time. I will not go in detail today on these. I will, of course, demonstrate 2 of them, a priori and FP growth again, how you do it in the cloud, but this will be also part of your assignment 3, right? So I will keep it to the degree of that you understand the cloud environment, that you understand how to create the kernel that is necessary to get then one package, the MLX10 package that we need to execute it. So if you need to know more about the algorithms, I refer again to lecture 11. I think Shadi has nicely illustrated how that works. You see it here again through the different levels of the so-called support and the counting of these, let's say, triplets or 2 item sets, triplets here. You come more and more to the idea of creating this in the a priori algorithm. But in a way, it's an algorithm that doesn't scale as we've seen. Hence, there was a more, let's say, more tree-based approach instead of an iterative approach, really, to go again and again and again through the data sets to create these 3 item sets, 2 item sets, etc. So the tree algorithm is much more smarter, like, computer science in generally suggests that tree algorithms are having quite a good performance. And we have shown this basically when you here see it in example of a priori compared to FP growth here. The sub is then a set of parameter. Also, this is something I cannot, demonstrate this too much. I will allude to some of the configuration parameters, but of course, this is really rich. You can have different thresholds, the minimum support. You have different configuration parameters, of course, how you can tune these 2 algorithms. We talked briefly about it, but then also Shadi had some of them in the slides the last time. However, I also want to come to an interesting example where you can see deep learning in practice again. Deep learning is now obvious to you. You have seen that in lecture 7 and 6 and so on. So here you see deep learning, how it works in a practical, let's say, project really with a perfume store we work with. And Shadi was talking with you about it, where deep learning was used for different interesting use cases. And one of this, when a customer comes in the store and I want to have a perfume that looks like a gold bar, this is something where then the clerk, or basically the one in the shop, needs to look up in the database and see, okay, what of the perfumes is actually looking like, let's say, a gold bar, especially if, big shopping stores where the person is maybe not completely trained just for perfume, right? But these are common questions, and you can see that the gold bar was just the simplest examples. I mean, many of you know probably the perfume that is basically behind that. So I don't want to tell the name here recently, but I think many of you know that. But the databases usually that the shops get from the producers is actually having not color, shape information or something like this. So what Shadi and others in the project and we did was using then deep learning to really get with something that Shadi was alluding to is ImageNet, a pre-trained network, actually enhances a little bit. It shapes colors from another script in order to get, let's say, an augmented database that will have this information now automatically generated based on pictures that we got from the different perfumes, and it's now associated to the database at this particular store. So we can now answer the question, well, which one is looking like a gold bar, and the clerk can look it up and see, well, that is this one, you find it over there. So hence, this is of course just the most, let's say, simple example that you can take away from really practice. Now think about that. The perfume industry has been evolved quite rapidly. There are, let's say, perfumes that look like lady shoes. They're looking like a wine decantier you see here, red wine decantier, or you see crystal, a bear, hand grenades actually. So there's lots of elements. When you look a little bit, maybe in the next time in the perfume store, I would recommend you to have a look. It's quite interesting how many forms they come up with. So the gold bar standing is just for, let's say, a big class of interesting elements. So deep learning was very useful for this particular element, and you have seen also Shadi last time has used it even for COVID research and so on. But I would like to go now to practical lecture 11.1. So we will look a little bit behind the scenes now to use another cloud. And I want to make, again, as usual, a couple of connections to different lectures. We are quite far in the course, so we can quite look back, but we will also see, you see all the 3 ones in a way are together. And I want to demonstrate this a little bit today with one of the cloud already, although you will see with OpenStack and Docker and all of that will come in a, let's say, later lecture. So I will start with the Jupyter environment that we have at the Supercomputing Center, where we have the JSC cloud. And this is something what you should use in your assignment. You will see that this is a Jupyter Lab environment. So we have to understand a little bit the difference then between typical Jupyter notebooks versus a greater Jupyter Lab environment. And also when you want to extend it like we want to do with the so-called ML extend library, which then actually has the a priori and FP growth algorithms implemented that we need certain elements. One of it is to create our own kernels in the Jupyter environment. And the other one is to understand a bit what the pip package installer is doing. This might be for some of you who are not really inclined very much in, let's say, deep down details, a little bit of, let's say, execution of cells, quite low level. And in this sense, you don't need to understand everything which is going there, just to understand again that when you create your own cloud, which I want to show you with this example, because the JSC cloud is based on OpenStack, then you also have to do some, let's say, more installations to get several packages. And of course, you have here and there also the flexibility to do so. Then in the second part of the course, we're looking more in the recommender systems. So also this is part of your assignment, of course. So we will look just a little bit of understanding recommender system at large. And then we would dive a little bit into a very specific approach called the collaborative filtering recommender, and then also optimization approach. It's using several, let's say, approaches in this area as well, but we focus a bit on the SVD and the overall idea of having a matrix factorization approach. By this, we learn somehow embeddings in this model that in a way then brings us to the recommendations that we want to have. And the interesting thing of the collaborative filtering approach will be not like we have seen in the association rule mining, where you would say, we can recommend, when you have diapers that people buy beer, which is very general. So the recommendation that we can derive from these, let's say, collaborative filtering approaches is rather, we can recommend this particular movie because people like you, which are very similar to you, bought this already. Hence, there's a personalized or let's say feature-based orientation around users, and I will make a case for it. Obviously, recommender engines, you could teach probably half the course. There's so many approaches these days, even with deep learning. But I think this is also one which stands the test of time and is very, let's say, broadly implemented in many packages. And again, we can make the connection to Apache, of course, and the kind of open source models that we had at Spark and so on. Hence, a kind of complementary lecture part then to the association rule mining and also how you use that with associations in the FP growth and a priori, thinking about that we then in the second part go much more into detail with movies and persons looking movies and rating them and so on. But let us start a little bit with the data mining techniques in clouds. So here I would like to start a little bit with conceptual ideas, thinking that the kind of cloud that you will see now at the JSC is not one of the hyperscalers that you know from AWS, MS Azure, Google Cloud, Google Collaboratory. It's something that JSC basically created themselves, right? Or we ourselves. I'm still JSC also, right? So in this sense, we used OpenStack, and my colleagues in the JSC really picked several blocks out of this in order to create this. And this brings us to the fact and to the demonstration of, something we will learn in lecture 14, but that you already see demonstrated works relatively well for, let's say, a cloud, let's put it cloud vendor that is not one of the hyperscalers. So hence I told you earlier, if the boss comes in your office and says we need a, let's say, private cloud somehow in our own organization, you would say, okay, let's take the OpenStack cloud approach, and we will talk about it. There are different services again, and when we now talk about what you also have to use in your assignment, it's called the JSC cloud. It actually evolved a little bit from the HDF cloud. For those of you that checked the 2022 recordings of my old courses, that was basically the Helmholtz Data Federation cloud. Now we talk about this has been, let's say, advanced to the JSC cloud. And it starts essentially with the Jupyter website here. And I will demonstrate that now. I've opened that for you already, so making it more a practical lecture, right? So we have this Jupyter JSC fzjülich.de where you can, go to. It's easy accessible. Once you basically log in, you have to, either go for this and have a UDO login already created, or you take the register button, right? So this is something where those of you who don't have a passport yet should basically do the registration center part here, and then create your own, let's say, account by registering the email, send a confirmation mail, and then I basically add you with the next steps that are coming. And you see that a little bit here. I put that also on the slides for you, how that works. So in order to sign in at the cloud, you have to do first this UDOR, create a registration with your email, and you get a, let's say, email back where you can then submit a request where you have this JOIML, that is the project, as I wrote also in the assignment description, and just make some additional information that you're a student in class. So this gives me the opportunity on the other side to grant you access to basically the Jupyter environment. And let's come back to this. You see also then when you use it in practice here, that essentially, many different tabs open here. So that we also think about that there are different systems we can have access to, right? You see here a bit on the bottom when you are at Jupyter JSC, we have the Jewel supercomputer, we have Jureka as a supercomputer, JEDI is the first part of an exascale supercomputer. So things I teach much more in the HPC course. Yusuf, another cluster, the deep cluster that some of you already know, and the JSC cloud. Hence, here with this Jupyter Lab at the Jülich Supercomputing Center, this is a portal where you can access many different systems. And this is all again fueled in basically the OpenStack environment as a front. Of course, you have to have the hardware in the back. When you come to the documentation that I added here to the JSC cloud, you see that as well. The JSC cloud comprises OpenStack, compute, network, and volume services, as well as an integration to the data systems and file system that we have in HPC systems so that you can share data and so on. Hence, there's also more OpenStack services, and I will make the case for it, of course, in one of the coming lectures, right? So just that you know, this is not something where AWS, MS Azure, or Google Cloud is having their fingers on, if you want. So this is really created at the Jülich Supercomputing Center using open source tools, and it is really in production. You see that quite nicely here. When we want to sign in and you have done a UDOR account, one of your next steps, is then to agree in Jupyter JSC production that your data is being transferred, right, and used for authorization and authentication here with OpenID. And also in your assignment, you have to allow for this. So this is just that you give your consent and basically can log into this environment. Now, having done this, let's come to more practice here. You see there, you come to the Jupyter Lab environment being logged in. You see my login here. Your login will be looking a bit differently, but you have still, of course, then the Jupyter Lab environment. You see also here that I have, used that since quite a long time. So there, even the course from 2022 is still there, but also for different digital twin data, machine learning projects, and so on. The deep access. Some of them are even not technically anymore there, but some of them I can start again. And you see one of that I've, of course, prepared a little bit for our lecture today to save some time, is something where we want to work in. So it's running. We can see how that is basically configured. It has a Jupyter Lab version 4.2. Is assessing the JSC cloud, hence our OpenStack-based system. And then with a flavor that I could choose from, hence when you want to create here, for instance, new Jupyter Labs, and you see we can have it on deep system, HPC system, or the JSC cloud here. We can have different flavors, basically, of these systems for us available, and the flavors are a bit here shown also in terms of how many are available in the cloud. You can imagine we are not like Amazon, right? This infinite scalability almost. It's still a homegrown system if you want. And with this, there's many options there. You can get these kind of CPUs. Of course, here you see a little bit like, 9 are used from quite infinite, but in the end, infinite is also a strong statement here. And this is something that you should use for your assignment. So you will basically give this all a lab a name, and you should use it, maybe like your course name and so on, and then pick something like 4 GB, for instance, here in terms of which flavor you want to run. So in the background, what happens is lots of these OpenStack machinery that I said here on this particular slide with compute network and volume services are starting. You will understand that this will take some time. So you will see some, let's say, messages that, this is starting up and so on. And then in other words, you can use it after, let's say, a minute or so when everything has been started up, and looking a little bit like things and the slides here is of course something also is basically what I also demonstrate you in the live demo here. Also to say that it's really production status. We have used this. You see me here with my fellow professor Gabriel Cavallaro here, teaching with Jupyter many times machine learning and deep learning and so on in many tutorials since quite a while. It is really having grown to production quality in the beginning, and maybe it was a bit shaky, I think, because we have done it ourselves, we created ourselves, and this of course takes some time to get it to really complete maturity, but it is possible with OpenStack to have quite high, let's say, usability and production stability that I wanted also to demonstrate. Also the functionalities you see here, when we now come back to the practicals, let us look what happens if I now say open. I already open it here in one of the tabs, a second here, where we are already then in the kernel Jupyter Lab environment. We see here several things uploaded that are relevant also for today for the demonstration, association rule mining and so on. But we can also have a new launcher here, where basically we have different kernels to choose from and different prepared environments. You see here Pi deep learning would be perhaps the Python deep learning packages we want in order to do deep learning, for instance. You have the typical Bash. You have Julia, one of the programming languages gains popularity. You have R, a statistical data mining and learning environment really that is often used in data sciences until today. Although we have to say Python getting more popular, still R is often used. And you can create notebooks here and start crafting. Let's say if you have a Pi deep learning, this is an example here where then, we're starting this, we can start crafting our Jupyter Notebook elements. And I don't have time to give you a big demonstration, but the kernel will be an important part today because we want to create our own kernel, right? These were kernels which were, prepared, and there are other kernels already available. You see here for our system sciences, for instance, specifically for quantum computing, people have created kernels. And you see here one kernel that will be important to us because I also created it extra for this course. And when I say I created it, that means I, of course, had also great help from one of my colleagues. I want to appreciate here also Heman here. You see Heman Miyeni, that actually was basically providing a kernel setup script that I just go to briefly, not to take too much time because it is a relatively low-level aspect. It just show you that you can create your own Jupyter kernels if you want. So it's a stepwise process based on the original script we got from one of my dear colleagues here in Jülich, Jens Hendrik Göbert, who provided this more generally. And the original source has been now from Heman tuned for our course so that we can basically implement our own pip install ML extend so that we get access to FP growth and the association rule mining. Hence, when we talk about creating your own kernel, we need to, let's say, close this here. In order to do so, we have this setup kernel script here that I basically have also on the slides now. So let's move a little bit through it. I will not basically create the kernel again. That is also part of your assignment to do that yourself. And with this, you can then do, basically the idea of the following description that is also in the assignment using FP growth and the association rule mining scripts. So we have a couple of steps by creating the Jupyter kernel. Of course, we have to have a kernel name. You see here, we have basically chosen the course number, which year, and so on. And who am I? This is a name that is basically coming from the system. Then we want to basically have a kind of Jupyter lab and the kernels that is searched for and the directory for it. Again, so the really deep down details here is something in this particular course you don't really need to know, just that you have a reference. Let's say in case you are in an environment where you have to create your own kernels when you are coming to an organization and you have to create your own cloud with a Jupyter notebook, you have a reference how that could work. So let's come a little bit back to this here, where we then have different paths where we can configure the kernel specifics. Also, this is not so, basically important. It's more to think that it's a private kernel for you. So of course, you can choose to share this, as we have seen with many others. Let's say we have seen the Earth System one, where you then maybe as a head of a group want to share it with the data analysis team in your whole organization. There are different ways how you do it. We here have a private kernel, so every group gets its own kernel. And then basically having a so-called virtual environment or the kernel virtual environment where there's a directory which we're going to use in order to create our own, let's say, virtual Python environment inside. This virtual Python environment is sort of important, and this has different reasons. So one is usually that in clouds, you don't really can always do a certain command like pip install or change the configuration of, let's say, applications and Python packages and many other things that are already installed. You need administrative, let's say, rights for do it, right? There's certain rules in companies. Some have the right to install things. And this is also true for Jülich, for instance. Of course, we have several administrators that work, for instance, on these modules. The module environment is also quite loaded. So hence we talk in the HPC course much more about it's a very low level environmental system to create the environments of applications for specific software. And if we go now here through the real script, we see the software that is available in different stages at the JSC cloud already. So where people have already, let's say, installed this via the module environment, we see different, let's say, Julia again, we see HDF5 as a parallel file system format. We see CUDA versions for NVIDIA GPUs, they already know. SciPy, we see different bundles here, maybe coming also to some where maybe something in data sciences would be SkyKit here. All of these basically are available, but what we miss here is now when we look at this, there's no ML extend or anything which would be this Python package we're searching. This is also the greater modules. Thinking about that this is something for us really that we need for the FP growth and for the association rule mining. Hence, we need to install it. And in order to install it, you need to get the Python versions right. So which is another part of what you see essentially here on the top when we say, wait a second, here we start with the stages, which is a baseline. Then we have the Python, which then requires a GCC core to be available when we want to have, for instance, Python in 3.11.3, so a specific version. And, then we list all the modules which are there and check also the availability of the modules. So having done this once, of course, then you can use a kernel without going through this again and again. I just make here some examples describing it a little bit more, because you can imagine that this has much more lower level dependencies. And in the HPC course, we talk about that much more. Still, it's for you good to understand that underneath, you have, of course, similar, let's say, hardware infrastructures, right? We talk about on the infrastructure as a service level, which needs them. These software that we're going to use now on the more, let's say, platform as a service level on the Jupyter platform for doing our, let's say, notebooks and so on. Now, the next step is then to think about module load Jupyter Lab. So this is an environment which is larger than just one Jupyter notebook that you already know from maybe other, let's say, cloud vendors we already looked at. In MS Azure, we have started the Jupyter Notebook, but Jupyter Lab is a bit bigger, bolder. It has also sharing of data, and there's different launchers and kernels and so on that we can use. Then we install certain Python libraries, which are recommended and required here and there to make it really integrated into the, let's say, Jupyter environment. It's a bit special that it's not just on the command line. Hence, there needs to be several different pieces that we also need to have installed, which is then done here in this pip install IPython kernel. Having also something to do with interactive approaches that we have here, right? We don't really have an approach where we have a batch submit, what is often happening in these, let's say, rather hardware-oriented systems. And the Jupyter Notebook is a good example of this interactive access, because we want to, go here through this. We want to create, this and execute it, having new cells and so on and so on. So going quicker, maybe then to the next step, pip install MLExtend is something, and of course, what I just discussed with you here, I put you a little bit on the slides, but take away the message that not all of these details are necessary for everyone to understand. This one is a distinct exception. Maybe you have to understand that the algorithms we want to use a priori, or the FP growth algorithm, for example, are part of a specific package, the MLExtend lib, right? And you can have the documentation here in my references 7 for the a priori, but there's also one for FP growth. But this is usually not necessarily everywhere provided. So basically, this is the point of showing you this, right? With pip install MLExtend, and the different varieties. Sometimes you can do pip install minus user and MLExtend, which then puts it in the user space. Here it doesn't matter because we are in a virtual environment anyway. So in this sense, this is an opportunity for you to install new packages. So MLExtend is based then on the Python and can be used then with Python, but it's not part of the core package like many other extended libraries. So it's a good example. And MPI for Pi you see as an example as well is another package that some of you may know that have been used in basically participating in my HPC course. So these are packages that you can install to modify your environment. And what we do, we using pip now in the Python virtual environment we created upstairs in order to make it accessible to us in this particular kernel we create. Hence, again, now we're launching this Python virtual environment. And this must match the versions that you have also seen upstairs. So Python 3.11.3 is very important. Then you need certain other ones. You see also TensorFlow, OpenCV would be possible for us. It's now important to have Jupyter Lab. You see that here on this slide. And then, basically the environment is, so to speak, ready. We can edit and create this kernel environment further, doing several adjustments and configurations, which are not so important right now. You see, we can modify display names and so on of the kernel that you see on the top right, then in the Jupyter Notebook, and so on and so on. So in the end, when you go through the script, you will see that you have a new kernel available. And what that means, we have seen already when I now have this new notebook I created. I said I use a PyDeep Learning kernel here, but now when you go through this setup kernel script, then we have also this interesting new kernel available for us, which we have here. And we can, using it, you see it's disconnected, and then you have to wait always until the kernel is, started and being idle again. And then now you could, let's say, craft several different pieces within this environment. And this would give us now the opportunity to say, well, there should be now a pip install MLExtend possible, but we maybe don't need it because it's already installed. And that's the point I want to do with one of the next demonstrations, really. And here we just come back to this, think about the support learning from data elements that we will now have. The initial steps that you see on the coming slides will be always thinking a bit about the problem, data and data preparation, data understanding. And then, of course, there's a second part to it where we then talk about the FP growth or about the a priori where we do modeling, and then some evaluation that we have there. So let's start a little bit now, and this is something what I already talked to you about, the updated association rule mining here. And we don't need that anymore, but we need basically this one, particularly where we have here already loaded our kernel, right? It's active and running. So what I can do is here to do again an execution for each individual cell. And I start here by doing this. The first is doing a pip install mlxtend. And with this, you know, in front here, you can mimic essentially also system calls. So basically, we are here in the Jupyter Notebook environment, and I showed you this before already as examples. And this was just a test to see, is it really already there, right? And we see that basically that's the case. So you see the requirement is already satisfied because there's an mlxtend. Hence, we can now nicely use it with import statements, which would otherwise fail, right? When you do this, mlxtend, frequent patterns, the a priori and association rules that we want to have. So hence, we have also a retail data set uploaded that is part of your assignment. A very, let's say, simple one that is a little bit alluding to what Charlie presented already, you know, these kind of shopping basket, you know, not really millions of transactions, but quite a few that you can use with this and understand then how that works in the association rule mining. Again, the details have been already presented by Shadi. We load that here. For this, it's important that you upload this with this functionality here, upload files, not only the script that you have in your assignments folder or module on Canvas, but also the data set is required here. We read this as a comma separated file and then give out the head, so the couple of first, let's say, lines where we then see directly the analogy to what Shadi was presented. You see here also not a number. That stands for the fact that basically there was not more in the shopping basket here, just the 3 items, for instance. And then we look a little bit those which are unique, just to understand, you know, our shop, what items it's offering. And of course, here also think about that Costco or whatever you think about a real retailer, a big one, who has probably in the thousands of items, right? Again, the examples I do here for the course to stay in time and not wait very long for processing is of course something where you can consider in practice there's much more product variety, but there's also much more transactions, and all of that to analyze with data mining and then having the infrastructure for it brings it together to the so-called big data analytics approach that we have in cloud computing. So hence the combination, often we call them the big data analytics, because it's not only data mining old algorithms, they also need to scale, right? And here you see then now how we do some data preparation in the terms of CRISP. We did some data understanding by looking at the data set, how it looks like. We did the data preparation here of doing one hot encoding, where it says essentially what you see here already in the data frame. We basically do a one hot encoding now of saying which shopping basket has which item, and every time it has an item, we do a 1. If it doesn't have this item, it is a 0. Right? So it's for mathematical convenience for the a priori algorithm to use that. And here you see already some of the configuration parameters that Shadi was basically providing to you. So for those, I would essentially refer to you to lecture 11, because many of them are possible to choose to configure. And you see here a little bit the support and the item sets that we have. We can filter then all of those which are below 0.2 would be not of interest for us. And here's some strong ones that are often in common. Hence, we can do some association rule mining on it, which is also then part of this package from mlxtend, the next part. And you see here the antecedents and consequence. So people that buy this would probably also buy this. We have some confidence levels. So we could see here bagel and bread often go together apparently to a kind of high confidence. We have a high confidence that cheese, then people would also have some meat. Here, of course, the antecedent support and many of these items depend again on many of the let's say, configuration parameters. You have to see that you need a certain support maybe to see that it's really a kind of trustful rule, because you will see in practice when you have many of these rules, we just give out the top 7 here. Yeah, it will create many rules, but many of them have also not really high support, or basically, you know, depending on what your threshold is, that would be something where you have to be careful thinking about in practice. And some of them were already described by Shadi. So I think also, of course, we have these elements also a little bit here for you on one slide now summarized, right? Think about the parameter minimum support here would be this example. Let's move also a little bit to FP growth. If you remember, this is now the much more scalable algorithm following a tree-based approach. Also, this I would like to briefly demonstrate. And of course, in your assignment, the idea is that you explain that a little bit in your own words. You have to go through the setup kernel. That is not what you have to demonstrate and to describe, but you need that in order to execute the FB growth, right? So hence the setup kernel will be also soon available to you. We here don't make the test anymore for this one, because we are in our trusted kernel that was basically created gratefully from the provided script from Heman. So that we have now ML extend available. So we skip now the test, we can just execute it. Also from the dataset perspective, I just wanted to show you that, of course, you can also create your own dataset here and take it as a very simple example, a data set which is, you know, very similar to the one we have seen here for grocery. Then we have a transaction encoder that you can use. It's something which also comes as a pre-processing. Hence, we talk about, again, you know, the idea of having this one hot encoded, this times with false and true, which is basically very similar. You have seen there different ways how you do it. And this is now preparing it for the algorithm. So hence, we would say this transaction encoder in a way is now the crisp DM phase on data pre-processing, right? We pre-process the data so that we in the modeling that we have seen then later in the FP growth algorithm, executing it here again with some parameters like minimal support, would then be able to, you know, work on this particular data set. And then again, think about that we can have different minimal supports. We can tune the data set, having then, let's say, more insights over time, looking at more in detail when you have a production setting. Now, for this example, and then I think we are almost finished with the first part here. Your assignment will, of course, I think it becomes more obvious if you do it yourself and you see, if not the biggest examples you have here, but still the transformation is interesting to think about from the data perspective, right? So encoding this differently, the same amount of data. And then the FP growth, when we execute this with min supports and so on, it makes sense to go back to Shadi's slide in lecture 11 when you need to explain it in the assignment, but also per cell, just 2 lines, right? Not a big story. And then you see that we can, of course, also, you know, get some better understanding. For instance, here, that onion, eggs, and kidney beans seem to be quite often well bought together. That's more insightful than those 4 here, right? Which basically have a single. But then you see here, eggs, kidney beans have a support of 0.8. So you see, probably coming back to the original one, that many times you'll be shopping baskets with eggs and kidney beans and so on included, like this one, and, you know, this one not, but it's still this one as well. How that is computed and so on is all in lectures basically 11 explained from Shadi. So I will basically stop here, and then we will in part 2 come to another next step where we go a bit further in the understanding of data, and also, you know, having a different example than of movies and recommendations around this, understanding a bit collaborative filtering. But we break here for 10 minutes and then come back to the second part.